For decades, the so-called standard model in physics has been the gold standard outlining what scientists know about the basic subatomic building blocks of everything known to man. Over the years, they have identified 17 fundamental particles and 3 forces.
It's the electromagnetic force, the weak force, which is connected to nuclear decay, and then also the strong force, which is what basically holds, your protons and your neutrons inside of the nucleus and basically makes everything that we are, the structure that we are.
Renee Fatimi is a professor of physics at the University of Kentucky and is part of an international team at Fermilab outside Chicago. Partnering with the European Organization for Nuclear Research, or CERN, in Switzerland, the team is trying to unlock the subatomic secrets of the universe.
There's always this force, and it's a question of tapping into it. We're trying to figure out the new forces and particles.
An experiment at Fermilab aims to tap into the unknown. Of particular interest is the muon, one of 17 particles similar to an electron, a byproduct of cosmic rays. Muons constantly blanket Earth's surface. Fermilab used a specially designed 14-meter circular magnetic track to study how muons move through space. Data from billions of tests are challenging fundamental principles of the standard model known to generations of physicists.
We got a real hint, a real possibility that there could be a breakdown of all the fundamental things that we thought we knew.
Marcela Carena, head of theoretical physics at Fermilab, says the experiment is detecting phenomena that cannot be explained by the model that physicists constructed in the 1970s and updated as recently as 2012. Specifically, some unknown force or particle is interacting with muons in ways not predicted by the standard model. So, what exactly is it? Carena says data collected at Fermilab could hold the answer. Analysis has only just begun, but hints at the possibility of a major discovery.
There could be one or more particles that are starting to talk with the muon.
I knew that this result could be possibly a watershed moment for physicists. I mean, it's like finally now we have a hint of where to go next.
The particle breakthrough has led to a surge of interest in Fatimi's work.
Talking about muons and standard models, I mean, nobody talks about that over dinner, right? But hey, now they do, and that's super cool.
While Fermilab's muon experiment continues, Marcela Carena says the next phase of research could yield more clues by smashing or colliding the particles together. Doing that might require more advanced technology than Fermilab's accelerator or even the Large Hadron Collider at CERN's facility in Europe. Kane, Farabaugh, VOA News, Batavia, Illinois.